Hello and welcome to the 12th episode of the RockyTerrain podcast. Today is May 7th, 2021, so we are recording today on a Friday. The episode will be also live today at this Friday. My name is Thomas, and with me, as always, is Dennis.
Hello there.
In today's episode, we are I just see that I wrote down to speak, of course not. In this episode, we are going to talk about the movie Day After Tomorrow. We both watched it, and in this episode, we're going to discuss the science behind the movie, and also a bit the movie, if you liked it or not. So if you're interested in that, you're welcome to stay. But otherwise, before I will go into our main topic for today, some personal science news maybe. Dennis, maybe something happening in your life that could be interesting for us.
Maybe the first thing I'll talk about is what I just mentioned before we started recording, because, just today I saw that a complete description of a small ornithomimid dinosaur. They are often called the ostrich dinosaurs. You see, for example... Or is it? I think it's Struthiomimus in the first Jurassic Park film. You know, the ones flocking like birds, running away from the T-Rex. One of them gets eaten by the T-Rex. One of those dinosaurs, it's called Pelecanemymus because it has a throat pouch like a pelican. And I've seen that just today a full description of this dinosaur has been published after 27 years, and I'm pretty astonished because I absolutely didn't expect this dinosaur to not have been described in full yet. So, pretty cool. I think I know what I'm going to read later on. It's also a pretty early form of these ostrich dinosaurs. So... I don't really know right now. I think it even still has teeth. The later forms don't have teeth anymore.
Right, they have only peaks, right?
Yeah, but besides that, we are currently preparing for dig season. It has more or less started. We have started preparing the dig site near Balve in the Sauerland in Germany. I already found...
but if you want to know more about the stick site, we have an episode about it. I think episode 10.
Exactly, episode 10 is about this very dig site. Found my first fossil, a fragment of turtle shell, which is, special, kind of, because it's a fossil, but turtle shells are pretty common there. So that's pretty cool. Things are starting to move. We just finished working on the existing Iguanodon bones in our collection. A couple of episodes back I mentioned that these bones have a certain mineral embedded in them, which was embedded during fossilization. And this mineral tends to break apart in contact with the atmosphere, so they have to be stored in airtight bags. And we had to check all of these bags, whether they were still sealed or not. And we finished that. And then yesterday, our boss came up to us and was like, hey, we still have this gypsum cast of a life-sized Iguanodon in the collection. And it has to be replaced into new crates anyway. So, you know what, let's go ahead and just put this thing together. And I might remember this day very fondly in the future because, damn, this was just pretty cool because you had the opportunity to put the bones together and to just get an impression of how Iguanodon anatomy works, and then discussing this with our boss, who is way more experienced than us. It was very cool. It was truly, truly cool to just have this complete skeleton. I mean, we didn't really fully build it because you need a framework, a metal framework to place the bones into or the casts into. And we didn't have that, but we laid this skeleton out before us, in front of us, on the ground. And just seeing the dimensions of a fully grown Iguanodon, it's very impressive. So...
Yeah. I mean, that's the thing that you want to do in the future. So
exactly.
It's like the first time. So, yeah.
Yeah, I think it feels like kind of the grand finale of my time here in Münster, because the master's degree is coming up. I'm going to move to Bonn to make my master's degree there. And yeah, this was kind of... It felt as if my time here in Münster had been building to that moment. The first time really building a dinosaur, really having a complete dinosaur skeleton laid out in front of you. I mean, even if it only was a cast, it wasn't original. But yeah, it replicates the original anatomy, so... And you never really can compare studying pictures and papers with actually working on the real thing. So I'm thankful for that experience over the last few months. It was pretty cool.
Yeah, also sounds pretty cool. I like the pictures you posted.
Yeah.
You also posted them on Twitter, right?
I posted them on Twitter, yeah.
Cool. So if you want to see the pictures, go on his Twitter.
Yeah, but what about you?
Also busy week. So for me, the lectures have started again now some weeks ago, and you're kind of starting to go into the normal procedure of the semester. So a lot of things to do for university. I think master lessons, you have to do more work for master lessons. Like overall, we have less lessons hour-wise, but we also have to do a lot of work for all of these lessons, like reading stuff and some homework stuff, for example, and reading papers and trying to answer some questions about papers and so a lot of things to do. A lot of things to do, nice. Lots of things to do.
Much thing of grand magnitude.
Yeah. Otherwise, I had very special meetings this week. So I'm kind of involved with the ExoMars mission. So I'm working on a project together with our university and the DLR, the German Aerospace Center. And it is something that is connected to the ExoMars mission, especially to the ExoMars rover mission. So the first Mars rover of the European Space Agency, which will launch next year. And I'm now allowed to go into these meetings, especially the PenCam meetings. This is the camera, so the head of the rover. If you look at the rover and it has this head, that's basically the PenCam, this camera system. And I'm now allowed to go into these meetings. And this is, of course, pretty cool. Just to feel like how these things work. To see how such missions are planned. What things you have to keep in your mind. And what things that have to be discussed. And that's incredibly interesting. It wasn't always as easy to understand. Because, I was not involved in all the time before, so there's just many things that I don't know of. But just in general, to see how these people are working together, planning stuff, and pretty amazing. I mean, I'm not going to talk about what was discussed, but just in general, I feel very honored to be able to, just to, even if I didn't say anything, just to sit there and listening. It was pretty cool.
Yeah, it's the first step.
Yeah, and it's a very cool project, I have to admit. It's a very, very cool project. Yeah, anyway. So much news. So let's go into a small break and then get back with the main topic of today, which is again the day after tomorrow.
Yeah.
How scientific accurate it is.
Yes. Yes, it is not.
Yes.
Oh, damn. You're gonna see.
You're gonna see. So the day after tomorrow is the movie that we watched this time. For episode 6 or 7, we watched Dante's Peak, which was a movie about an volcanic eruption in the US. And back then we watched the movie and then reviewed it on the podcast, and we both were very surprised about that movie and how scientific accurate it actually was, in many parts at least. And we ended up actually liking the movie in many aspects. So we thought, let's do this, again. And we started watching The Day After Tomorrow. This movie was directed by Roland Emmerich. Why did I can just pronounce it German. Roland Emmerich.
Roland Emmerich.
It was released in the year 2004. So yeah, interesting movie. Maybe I would just, at that point, should we maybe just start with the question that you like the movie before we go into detailed review, or do you want to explain the plot first?
No, I think we should once again maybe start with just the short commentary, whether we liked it or not, and we can get into the nitty-gritty details, and there are a lot of them later on. Yeah. I did not like this movie. Don't get me wrong, I think Dante's Peak, it wasn't a brilliant movie either. It's not nowhere near in the vicinity of my favorite movies or anything, but Dante's Peak, there was at least some effort involved in the science. And honestly, after watching The Day After Tomorrow, I still don't really know what's going on. So, no, I would go as far as to say it's one of the worst. Yeah, one of the worst. I struggle to say worst, but one of the less good movies I've ever seen. What do you think?
Yeah, so I think we both recognize very early on that this movie isn't about the science. And I think you will discuss that later in much more detail, but that movie is just it wanted to tell a story, and it needed some start point. So it took something that is science, and then it just did whatever it wanted with it. So after that, I realized, okay, so it's not about the science, it's just like a movie, a catastrophic movie. No, disaster movie is what you call it. Maybe it is a catastrophic movie, but at that point I want to say it's a disaster movie. And I actually like disaster movies or disaster films. Just, I don't know, most of the time they're not very, how do you say that?
They aren't good movies.
Yeah, but I kind of still enjoy watching them just because it gets your mind off, and it's somehow always a bit funny and interesting to watch them. But in this movie in particular, I had some difficulties because it was so far off in many aspects. Still better than 2012, but it had some parts that I actually enjoyed, visually especially. But I search for words here. It's definitely not of my favorite movie ever. It is far from that, very, very far from that. it's one of the movies I probably will forget within the next weeks. But I enjoyed watching it. I did not feel like after I watched the movie, I wasn't like, well, that was time that I could use differently. I kind of enjoyed watching it, but I didn't like it.
Yeah. We decided to split all of this up into 2 parts, basically, because, the plot isn't really too relevant for the goings-on. Because other than in Dante's Peak, this movie doesn't really tell the story or the chronology of the events through the eyes of the characters, through the eyes of the protagonists, to be exact. But we get tons of viewpoints of people we never meet again, never met before. They do this to show a global perspective on things, but the plot is basically an amalgamation of a lot of tropes, a lot of cliches about science and nature disasters, and therefore it's really not necessary to follow the plot as we did with Dante's Peak, because in the movie Dante's Peak, the events were seen through the eyes of the characters. That's not the case here.
You learned what is happening because the scientist told you what is happening,
Yeah.
It's kind of like,
their story was directly influenced by the goings-on. I mean, here it's 2, but it could have been anybody's viewpoint. Outside
it's really
of
interchangeable.
Yeah. And the plot itself is also
it's kind of like a basic plot that every disaster movie has.
Yeah, it's just there need to be some odds. The protagonist, Professor Jack Hall, is a paleoclimatologist. So what he does is he works on reconstructing past climate, and also looks at what implications could this have for today, what observations can we make on Earth today, and what does this mean for what happened in the past, and so on. And he focuses on the last ice age. That's his topic of research. And he's also practically, the one who is right about everything that's going to happen, because of course he is. That's one of the first tropes we get. It's this one scientist who has this one story, this one theory to explain everything that will happen. And of course, he's the outcast. He's the one nobody truly pays any attention to, even as things start happening exactly the way he predicted it. And he's just he's a trope machine, because you get that he's not, he isn't socially awkward. That's one thing. Most movie scientists tend to be this socially awkward people. They don't like being around people. They're not good at talking, which scientists, need to be in most cases.
Maybe need to be, but not necessarily are,
But he's neglecting his family. Or to a certain degree, he's not a bad father. That's not what you get. He's just, he seems to be divorced from his wife. At least they don't live together anymore. Their son lives primarily with his mother. And you, in one scene, you also see that he isn't really that up to date to what his son is doing. He cares about him. As I said, he's not a bad father, but it's this whole, he kind of neglects his family for work. He's really obsessed about work and yada, yada, yada. It's this thing you get very often with professors in movies. Or scientists in general, that they're basically mainly consumed by their work. Not that something like that doesn't occur in reality, but it's like that all the time.
Yeah, it's like,
Yeah. And Jack Hall has this theory about melting sea ice leading to basically ocean currents seizing, which then stops warm water to flow towards the north, limiting the heat supply for the northern continents and thereby leading to basically the northern hemisphere falling back into an ice age. I mean, of course, what we get is way more extreme than only that, but that's that's the theory he has, and that's what's happening throughout the movie. His son, I talked about a few moments ago. He's pretty intelligent. He's a smart kid. He even in the film flies over to New York for an event for pretty intelligent and talented students. And that's the setup, because while his son is over in New York, signs start to show up that his predictions are coming true. And then on the one hand, he has to try and convince everyone that what he predicts is going to happen right now. And for some reason, most people still don't believe him while things are occurring just the way he predicted them. And at the same time, he's trying to come up with a plan to save his son. He then makes his way over to his son to New York. And in the end, he doesn't even really save him. He just goes over to him, and as he arrives at the same time, does an army helicopter. They pick him up, and of course, people have to flee from the north, because, you can't live under basically tens of meters of snow and ice. Everybody just moves to the southern continents, and it has this weird ending where it's just everybody lived happy ever after, despite the fact that half of the Earth's surface, or at least a significant part of the Earth's surface, is no longer accessible. And keep in mind that people flee to places which aren't necessarily that suitable for life, because it's just said that they flee to the south.
Yeah.
So I don't know.
Particular Mexico.
Mexico.
I wonder, like, probably Europe. People in Europe would probably go to like Africa,
Europe.
But that wasn't shown in the movie.
Europe is completely neglected. Europe is, Europe, it's literally one scene where someone looks out of a space station down to Europe and is like, yep. Oh, yeah, they're gone.
And the Scottish scientists.
Yeah, that's the other thing.
But we just see them inside a building.
It's very North American centric.
Yeah.
Most stuff is just portrayed for North America, and Europe, it's just, yep, they're gone, moving on. And literally and
Asia, of course, too.
Yeah. You just see the outline of these other continents. They're completely white, and that's it. But that's the plot for you. It's really simple, and it's interchangeable, and I gotta say, it doesn't really have much to offer for me.
Yeah, true.
Do you have anything to add to this part?
Nah, I don't think so. I think everything is said what needs to be said.
Okay, because then we can now just focus on what's happening in terms of the disaster, or in terms of the more scientific stuff, I would say.
Yeah, so let's go through everything that's happening, and in the end we try to put it together and see what actually is happening and how does this reflect real life.
Yeah, yeah.
Yeah.
Although despite the fact that this is not directly related to what's coming later, I would like to at least go over 2 scenes from the beginning.
Yeah.
Because the very first scene, the opening scene, is one during which a team of researchers take ice cores from presumably somewhere in the Arctic Circle. I don't think it's disclosed where exactly it is.
Oh, I think Antarctica.
Okay, then I didn't.
But I'm not sure anymore now. But I thought it was Antarctica.
Yeah, and why do you do that? What they're doing is they're drilling down into the ice, and you can think of ice, big bodies of ice, as some kind of an archive. It's basically a bit the same as it is with rocks. Rocks are deposited continuously in at least sedimentary rocks, and they document little facts, little hints at the environment they were deposited in. And ice is kind of the same in that regard for different things. I mean, because ice mainly documents stuff like atmospheric composition at the time of deposition and stuff like that, source of the water to a certain degree. And yeah, that's what they're doing. They're trying to get ice cores for research.
Good for climate studies.
Yeah.
Especially like from the last ice age.
Yeah,
like
exactly. I mean, because ice, of course, it doesn't reach as far back as rocks do, for instance, but yeah, for thousands of years, it's definitely still a very good source of information. Yeah, and then in what is presumably, I think, tens of square kilometers of space, a crack forms, of course, runs directly through the camp of our scientists, parting the scientists, all 3 of them, from their precious ice cores. And that was the first time this movie actually rubbed me the wrong way, because once again you get this obsessed scientist trope, because he risks his life, jumps over towards the other side, gets the cores, and jumps back over the crack with them. And
also, it isn't like they have taken several courses like before that, you know?
Yeah, indeed. And I mean, even still, he could have just, walked 100 meters to the west and could have taken another core there.
Yeah,
it's
exactly.
Yeah, that was the first sign of trouble. Yeah, but after that, the next scene, this is where the ice cores come into play. We get this press conference, which was actually my favorite scene of this movie, because it was a very nice breakdown of actual communication and general political issues we're still facing till this day. This film is, by now 17 years old, but it tackles relevant topics still for us. This is where we meet Professor Jack Hall, the protagonist. And basically, he's holding a talk in front of politicians. And he talks about how the climate changed 10,000 years ago. And basically, this is giving us the setup for things to come. He talks about how CO2 increase in the atmosphere can cause temperatures to go up, and how a 200-year ice age was started by such a process. And what was done pretty well, I think, was that by that point, someone in the back row, I don't know whether he was supposed to be a politician, maybe a journalist, he remarks, why would warming cause an ice age? This is, of course, actually, I think this is pretty important because, yeah, of course, this sounds pretty counterintuitive. And I like that they build that in there. I mean, he could have just proceeded to explain it, but of course, it's a question people ask when they hear stuff like that, because it's not really intuitive. And he then proceeds to explain how warming can cause ice to melt at the polar ice caps. And maybe to give a first little introduction, this ice melting can severely interrupt ocean currents. And maybe, Thomas, would you like to go a bit further with that?
Yeah, of course. So, as I said, there are like two important parts here. So first of all, the ice melting does decrease the salinity of the water in the Northern Hemisphere. And that's important because ocean circulation is extremely important for our climate today. And he especially talks about the Gulf Stream. And the Gulf Stream is water or current of water and circulation of water, basically, that takes water from North America, southern North America, brings it to Europe. So warm water is brought to Europe. That's why we have in Europe a warmer temperature than we normally would have without the Gulf Stream. Then in these like northern areas, the water starts to cool, and then it has a higher density, it starts to sink. But also the water freezes partly, and in the ice there will be only fresh water, and all the salt in the ocean water will stay within the ocean. So the salinity also increases, which makes the water sink. And because it sinks, new water has to replace it, and new water from the south is pulled upwards. And then you have the circulation of water. Warm water is coming to the north, sinking, cold water is being pushed back, and it warms up again and is again pushed towards the north. And, well, an increase in the temperature, in the atmosphere temperature, would first of all result in a melting of ice. And this would reduce the salinity. Salinity?
Salinity.
Salinity, right. So that, well, in the end counters the sinking of the water. And then secondly, just generally a hotter ocean and warmer ocean would also reduce this effect of sinking. So all of this together would result in a reduced Gulf Stream, in a reduced circulation of ocean water. And as I think you will then explain, would lead to probably colder temperatures in Europe, because no more hot or less hot water from the south is brought to us.
Yeah. And I mean, that's not only relevant for us, because before, as you said, before it arrives up here, it passes North America.
Yeah.
So that's of course what he's going at. So he explains that, and I think this was done pretty nice. And at that point, I still was very positive about this movie, because I thought that was a very nice introduction to this topic, especially to the more weird and less, I keep saying less intuitive, but it just really, I think, sums it up nicely.
Yeah.
It's good that they explained that. And it's also, it doesn't even only end there, because you get further discussions, because the vice president actually chimes in and says that, while the climate might be vulnerable and difficult to handle, so is economy. He calls the scientists, or he says something along the lines of that he's not really buying this sensationalist theory. He just puts it off like, of course, you would say that because it's sensational and it's exciting, but basically he doesn't really take it seriously. And that's, of course, it's an important discussion, because economy is...
It's a discussion that we have to do in real life.
Exactly.
Yeah.
I mean, it's just, of course, here in this case, that's why I brought this up with sensationalist, because, of course, the politician in this case is meant to be dismissive. He's meant to be, I mean, he works against the protagonist. He needs to be dramatized. He needs to do something to present an opponent against our protagonist. But of course, that's a discussion to be had. We know that we need to change our ways, but this can't just happen without any solution to other questions. This discussion, economy versus protecting sciences, that's an important one.
It's very close to real life also.
Yeah.
That's like the point.
Exactly. They bring up important topics which play out like that in real life.
In a very short scene, like a very short part of the whole movie.
Yeah. It's just science is trying to say what's actually going on, but everybody is trying to defend the own interests. I mean, of course, science is kind of, we're not protecting our interests. It's not our interest in a sense to protect the climate. It's just that he's saying, we have a problem. And it's like, again, like in real life where people... And the problem is, it's like science that says that's what's happening, or that's most likely what is happening. But then people are like, but the economy. Yeah. But that's not how this discussion should work. It's like we're saying that is happening, or scientists are saying that is happening. Yeah. And then we have to search for solutions together. It's not an argument if you say a problem that, of course, happens or is inflicted through that. But then you have to discuss a possible solution. Yeah, but I mean, that's just the way it's presented. It's just to create a conflict for the film. Therefore, it's presented like, of course, it's just one view, one opinion to be placed against the other viewpoint of the economy. Exactly. I mean, that's exactly how it is in real life, sadly, also the case. I just wanted to make this point that in fact, it's not really that scientists try to defend their viewpoint. It's just that they're saying that's going to happen and we need to do something about it, or otherwise this will take place. Yeah. It's not that we have an interest in changing our ways of life per se. It's like, I'm not going into that, but it's like, it's not that the scientists want these things to happen. Climate scientists don't want climate change to happen. After his talk, Jack Hall meets Professor Retchson, who leads a climate research center in Scotland. And, they get to know each other. You know that you get the sense that they're familiar with their work, and they decide to keep communicating. That's basically this first little scene. I would now start with the actual events, if you don't mind. Yeah, let's go now into the science part and see what's happening. All right. So the first things really happening is storms are everywhere. You get a sense that things are in a state of unrest, because it's really subtle at first, because you see storms in the US, you see storms then in Scotland. And at first it's not really, of course you get the sense something's happening, but it's not too dramatic. Yeah. It's like, could be background, just some storms. But it could be for dramatic effect. Yeah. But in this case, it's actually foreshadowing, or the first symptom of what's to come, because we are at Professor Retchson's Headland Climate Research Center, I just mentioned, in Scotland. And there's a storm raging out at sea. they basically have these buoys with thermometers on them all over the Atlantic, and I guess also the North Sea. They basically monitor ocean currents and ocean climates. And all of a sudden, one of their thermometers shows a 13 degrees Celsius temperature decrease, which is considerable. This doesn't happen like that all of a sudden. And of course, actually, it's kind of realistic because, of course, at first they react like must be a malfunction, because in our reality, in our universe, this wouldn't happen.
It was also this one random, measurement point in between all of these other points.
Yeah.
They check one randomly out of several that are very close to each other.
Yeah.
Which was also very interesting.
I mean, of course, ocean temperatures fluctuate. That's not the point. It's just all of a sudden, and it's this one data point. And this bad weather keeps building up. We get a shot from, we discussed this earlier, not ISS. It's kind of supposed to be ISS.
Yeah, but it has it looks differently. It has another model. I don't know.
Yeah. They see storm systems building up over the US. Bad weather report comes in from over Cape Canaveral. The next thing we get is this hail from Japan, I think. Yeah.
Exactly. We see Tokyo and head-sized hailcorns are falling from the sky.
Yeah, exactly. So also northern hemisphere. This is all going down in the north.
And at that point, I still thought, it seems like they're still at least kind of following the science, because there's actually some studies that say that hailcorns could get larger in hotter weather. So if the temperature wall is higher, then hailcorns could theoretically grow larger.
Yeah.
So at that point I was like, they're going through science and of course exaggerating it, but they're still searching for what things could happen due to climate change.
Yeah, at that point I was also still very much on board. It was like, storms brewing. I already got the sense that, it's going to be dramatized. And of course it's going to be, because we knew going in that this timescale of events would be off. Yeah, but at that point, still kind of realistic. Okay, let's see where it goes. We get a scene where Retchson from Scotland calls the protagonist Jack. And at that point, basically, the ocean thermometers document a continuously decreasing temperature in the northern Atlantic.
Yeah.
And did you also get it the way that this... so I don't know. That's the thing. Where did this coldness come from? I mean, I think that this was going to imply that ocean currents just stopped circulating because, of course, the warmer waters, just like predicted in the scenario going in this first press conference scene, ocean currents stopped circulating, therefore no warm water was coming from the south.
Exactly, that's the point. No new water is arriving at the northern hemisphere to Europe, and it's getting cold.
Yeah, and basically he tells Jack that his theory is the only hope because we've never experienced something like that, and yada yada yada. Of course he's going to be right. They calculate that ocean currents will change in 6 to 8 weeks at first. Or at first Jack reads 6 to 8 months. And then they're like, no, you misread it. It's 6 to 8 weeks. Bum, bum, bum. Flights aren't possible anymore because of the storms. And the storm slowly spreads over the US. And presumably other parts of the north.
Yeah.
Winter is coming.
For example, also the storm where it suddenly arrives in California, and
yeah, exactly.
It has to be some kind of other storm because
exactly. The storm, the tornadoes are spreading over LA, for example. Do you have anything to add to that in terms of research?
To the tornadoes?
Yeah.
I mean, we see like these large storms where tornadoes are growing from, which actually happens in real life. But the tornadoes are extremely, extremely strong and large. And, I've tried to search, like, for example, would tornadoes, the number increase due to climate change? And in the end, it's like, it's really difficult to address and to understand this topic. It's like, yeah, theoretically they can get stronger, but then on the same time, there are many studies. It's a complicated topic. That's the point. So at this particular scene, it was, of course, completely exaggerated. So I tried to look at it in a bigger picture. Anyhow, I found the strongest tornado that ever existed.
Which was?
In 2000, at least on our record.
Yeah,
in 2013, El Reno tornado in Oklahoma. It had a wider peak where it had its widest spread was 4.2 kilometers. And, speeds weren't measured, but they were probably up to 486 kilometers per hour.
That's a little factoid.
Yeah. So that was interesting. but no, otherwise, nothing to really add to that scene. Like, yeah, tornadoes destroying a city. So, okay.
It's just for dramatic effect. I mean,
it's
also of course, they want to highlight how quickly things develop because weather stations only recognize these tornadoes at the point at which it is too late. I also like the fact that when the boss of the weather station goes outside, he's like, or no, it's when the employee calls his boss, the tornadoes have already arrived in the city, in Hollywood, in LA, and he's like, yeah, we should maybe give out a warning.
I haven't even recognized it.
Yeah, I mean, the storms have already arrived, and he's like, yeah, maybe we should do something about it. Yeah.
But do we want to talk about these storms?
Yeah, I would get into that now because you have this excessive cold front building up in the north because of, the decreasing ocean currents, and that's why in the north things are getting cold. At the same time, now events are a bit convoluted because you have I don't really understand, to be honest, where these storms are coming from in the first place.
That's no worry because it's completely unrealistic. The point is, like, these large storms that we see here, these like hurricane-like storms, these are called supercells. And in supercells, like a large thunderstorm that has a rotating uplift in the middle, in the center, which is called a mesocyclone. Jesus. Like a rotating updraft, which makes them look like hurricanes. And the important part from these storms is thunderstorms form due to, they need some sort of energy, right? They have an energy budget, and they need some sort of energy to form a storm. And this is normally done by hot temperatures. Like if you, for example, have a warm ocean or warm temperatures at the ocean surface, then you would have enough energy to form a storm. That's like why hurricanes and things like these form. But we have colder air, temperatures getting colder. So where does all this energy come from to form these storms? Like,
Yeah.
that's just so contradictory. These storms would form when the ocean is getting warmer, but they form in the north where everything is getting colder. It just doesn't make sense that these storms form. They just needed some threat, they needed a threat that you can see, like a threat that is directly in front of your eyes, like something that is coming close to you and you should be afraid, and then the blood can go on. But it doesn't make any sense at all.
Yeah, and where this tsunami came from is a whole other discussion, because of course if you have all this ice in the north melting, this would raise sea levels, but this wouldn't be instantly, because of course, yeah, it wouldn't melt from now to the next moment.
Yeah, like for example, in the US, when for example the Gulf Stream would stop, then you would have several reasons why the sea level would be rising in America. So first of all, the Gulf Stream is like pushing water away from North America. So if that's not the case anymore, the water would rise. Then, as you said, you have like the beforehand the ice is melting and the water is rising, and then you have like this wind coming from north which pushes the water away, but it would not result in a tsunami. That's like it would like slowly start to rise and rise, but not in a 20-meter high wave crashing into New York. Also, when the storm arrives in, like the wave, I think in New York, you see like a scene where like in a zoo or something like that, and all the animals are freaking out.
Yeah.
And yeah,
this is just, you get this all the time. You get reports of of animals basically sensing danger. It's often portrayed as this weird connection to nature that man seems to lack. In movies as well as actual reports, it's often portrayed as this weird connection we just seem no longer to have, and in actuality it's, first of all, it's still kind of not really certain what is going on in all cases. I mean, animals sense changes in pressure and all kinds of things. And of course, you can't just lump all animals into one, because the specific abilities of different animals are very, very diverse.
Yeah. It's not like any animal that is not a human has this, like in quote, superpower. That's no. There's just some animals that have, for example, in a stronger sense for, the pressure in the air, and it realizes, oh, there's a pressure change, maybe is afraid of that and tries to hide or, run away from this pressure change. Or maybe the sound waves from the coming storm, which are the level that humans can hear, are heard by some animals, and they sense some sort of danger. They don't know what exactly is going on, but they are afraid of any danger that could come and are running away. But it's not like every animal has a superpower that humans lack.
Yeah, it's not that they know, tsunami. That again.
Exactly.
Let's search for high ground. So it's not like that.
Yeah.
And also the wolves escape, which comes in later.
Yeah.
Because of course we need to have wolves roaming the city New York.
Just for this one Jurassic Park scene in the kitchen.
Yeah. I fully expected the wolves to open doors. Which, interestingly enough, dogs can actually do.
Yeah, that's true.
Alan. I couldn't help myself. I had to look at my girlfriend all the time, whispering, Alan. Alan.
I also wrote just Jurassic Park in my notes.
Yeah. But anyway, that's where we're at, the flood has happened. The storms at some time cease, but you get the sense that the sea levels remain higher because the city is flooded.
Yeah.
Later on, you even see a large boat, a freighter, drifting into the city. Which is then stopped by a bus somehow. Tough thing. And now we have these quote-unquote hurricane-like storms. And what is now predicted by Jack and his team is that these storms suck down tropospheric air, which is for some reason so cold that it turns the center of these hurricanes into a freezer. And this is problematic for several reasons.
Yeah.
I mean, we are in the troposphere. Let's start there. It sounds as if it's coming from the stratosphere or something like that. Tropospheric air. You are sitting, wherever you're listening to this, you are still comfortably sitting in the troposphere.
Then they state like it has to be minus 100 degrees Celsius, but the troposphere is like at this coldest spot like minus 75 degrees Celsius. So that is kind of interesting. And then I think absolutely weirdest part that just doesn't make any sense at all, as I explained before, like the center of these storms is an updraft. The air is, being pushed up into the upper parts of the atmosphere. Air is being pushed up. There's no sucking. That's not how these storms work. Air is pushed up, not sucked down. This just doesn't make any sense at all. Any sense.
And then it's basically and then it's basically like this snow pencil. It's almost like a painting tool on a tablet, where wherever it goes, it just freezes the ground below it.
And people are like freezing in seconds. If it would have like not even seconds, like people are freezing in a second, as it would be like minus 0 degrees Kelvin. This is so weird.
Yeah, this movie completely lost me when it was implied. So the son of our protagonist, they're stuck in New York. The city is flooded. Flights are no longer possible. And they're just sitting it out because Sam's dad, the protagonist, Jack, paleoclimatologist, told his son to stay inside because, of course, he knows what's coming. The turbo freezer is coming. And they're just biding their time, and they're going through a museum, looking at a mammoth, and then there's some text given telling us that this mammoth had food stuck in its throat, and therefore it has to have been frozen within seconds, and it's implied that this happened before and maybe caused this previous ice age. And this was I jumped off board in that particular moment.
What I also thought was interesting is the when they were doing the models or like looking at the data. I don't know. The woman was meant that the temperature decreases or drops by 10 degrees per second. Now I don't know if they're talking Fahrenheit or Celsius, but it wouldn't really matter because this would mean that in some seconds the temperature would be close to minus 270 degrees Celsius, to the 0 Kelvin.
Absolute zero. You're in space, basically.
I mean, if it would go down to minus 100 degrees, like they were saying, that would mean that in 10 seconds. What? What? Yeah, that's interesting.
I would have liked if they would have at some point started sucking the air down so hard that they turn into a black hole.
Yeah.
Yeah.
I mean, it wouldn't make any difference because same sense is used in the movie. Like, could have also gone with that.
Yeah. Yeah, but this then, at least that's what I got from this, is what causes the northern hemisphere to freeze. That
Yeah.
all this cold air is sucked down and freezes over Earth, and this icing of the northern continent then would reflect light, because of course ice is white, and if you have vast swathes of land covered in ice, this reflects more light than, for example, normal forest would do, mountains would do. This would cool temperatures down to the conditions of the last ice age. And it's stated that this then causes Earth to be in equilibrium again. These raging storms would have been the result of an imbalance in Earth's climate conditions, something like that.
I mean, this actually makes sense to some degree because Earth is metastable. And not every condition of the climate is stable. That's something we call metastable. It can be stable, but when it's pushed too far, it can get in a runaway effect till it's stable again, metastable again. And these runaway effects with ice can happen, like ice is growing, the albedo is increasing, which leads to colder temperature, and more ice growing, which leads then again to a colder temperature. It's like a runaway effect. But like it's portrayed in the movie. Okay, so I think we've gone like now through all of the events that are happening, correct? Or is there like one event that I have overseen? I don't think so, right?
No, this is the point where things are quote unquote in equilibrium again.
Yeah. Maybe to get back now to the general point of the movie, and this is the stopping of the Gulf Stream, or of the... I think they mostly talk about the Gulf Stream, but I think they meant like all the circulations on the...
Yeah. I mean, of course, the Gulf Stream is also tied into a larger picture, and it's just this example. It's what influences North America and Europe the most, at least North America on the eastern side. Yeah.
So I also focused like on the Gulf Stream for that matters. Now we've talked before why it could decrease with an increasing temperature. But could this happen in real life, or is this happening in real life? And this is very difficult to say. There are some studies that say that the Gulf Stream is at its lowest or weakest phase since 2000 years ago. Now, of course, we can't measure the speed of the Gulf Stream 2000 years ago. We're measuring this actually only since 2004. But you can use like proxy data points, which are connected to the activity of the Gulf Stream, but not only connected to the activity of the Gulf Stream. So you have to be very, very careful about that. But for example, they looked at grain sizes in marine sediments. And the idea is if the water is flowing faster, then larger grain sizes can be transported. And if it's flowing slower, then the grain sizes that are transported would be smaller. So they looked at the grain sizes and how they changed over the last thousands of years. Then they, for example, also looked at ice core data to see temperature and rain, I think. Then tree rings, also to see like the temperatures in Europe. And then they looked at also oxygen isotopes. So they looked at different stuff. And they tried to pull it, push it together to get like an idea of how the Gulf Stream could have looked like some hundreds of thousands of years ago. Yep. Which is, of course, difficult to do, and they're not claiming that is how it is, because there's large uncertainty, but that's just the idea. And it seems like it is decreasing since 2,000 years ago, but especially there's a strong decline since the 19th century, when the CO2 emissions from humans started to significantly rise. And there's especially a strong decline since the 1960s. So there is a decline. However, and this is like the really, really, really important part, this is an extremely complicated system. Extremely complicated system. It is influenced by many factors. And nobody really knows what is going to happen or, why it is going to happen. Of course, the theory is correct. In theory, this could let the human increase emission or the increasing emission of CO2 or other greenhouse gases in that matter could result in a slowing down of a Gulf Stream. But some models show that, but other models also don't show that, and to what degree, yes, theoretically it could stop completely, but it's also kind of unrealistic. And then the question is to what degree. It is just so difficult to model because it's influenced by so many factors. That's just very difficult to do. Is there a tipping point, like a point where once you get over it, there is no return and it will stop or decrease faster and faster and faster. And then the question is how fast? Some say that this actually could happen within decades, which is extremely fast for on a geological scale.
Yeah.
Still much longer than in the movie, but decades are really fast when it comes to things like that. So, yeah.
But I didn't think that there... I mean, of course, that's just one model of many, I guess, but I wouldn't have thought that there could actually be the possibility of it ceasing within a decade or something like that.
Yeah, there is something that we also learned in our courses, and this is what I said before, this meta stability.
Yeah.
And it's difficult to say where tipping points are. And there are some models that predict tipping points. Like when you go at a point, there is no return. And in these cases, it could go really, really fast. And when we look at the last larger ice age, like the young Trias, lower Trias, I think it's called in English, then we see that it happened really, really fast. Like Earth was warming, but then it just was cold again, and then it was warm again. Like it was really fast. And these are the points, but again, it does not necessarily mean that due to climate change, the Gulf Stream will stop or decrease intensely. It could, but it doesn't mean to. Like, it's not like this is 100% something that is going to happen, like it's sometimes portrayed, I have the feeling.
And of course, it wouldn't happen in the way we see there.
Yeah, exactly.
It wouldn't happen within. That's also the thing. Their prediction or their predicted time of the events decreases during the movie. First we have weeks, then we have days, and then 48 hours. And that's and
no. The ice is just not coming in 48 hours.
Yeah, and it's really, as I said, they had to stuff that into an interesting action-packed span of 2 hours. But no, that's not how this works. And after 48 hours, you have this full-on, what looks like glaciation over Europe.
Like that's the next point. Like, what would happen if the Gulf Stream actually would like slow intensity or actually cease? And that's also a complete other story. Like, a complete other story. Yeah, yes, it would like release like temperatures in Europe would decrease, but to what degree? It would probably not be an ice age. But then again, on the same time, the overall temperature of Earth is increasing, so that like counteracts the cease of such an, or like the slowing down, I don't want to say cease, but a slowing down of such an of the Gulf Stream.
Yeah.
Like this could counteract. So there's some scientists that say it gets colder for a period of time, but then it gets warmer again very fastly. Others are saying maybe it's just that the winters will be more strong or more intense than before. And then some say, yeah, it will decrease, but only for, like, the temperature will decrease, but only for like 2 or 5 degrees Celsius less than we have now. Like, all of this are great changes, but I just want to say that it's difficult to model these things, and we don't really know what is going to happen.
Yeah.
Like, that's just a real life approach.
Yeah. I think that's also kind of the take home message. That's kind of the important thing, that this stuff is really complicated, but and also in current times where you see you see a lot of confusion about climate change. You see a lot of uncertainty because just a few weeks ago reports came in that here in Germany we had the coldest April I don't remember, unfortunately, but the exact terms, the exact words, but this April was below average. It was below average in temperature. And this report also included a phrase like, is this evidence against climate change? I mean, they dismissed it themselves. Okay. They themselves explained, no, definitely isn't. But it's so important to understand and to try and explain that fluctuations occur all the time.
Yeah, and that is the point. Like, you're doing an argument about climate change, and then somebody will say, but it's cold outside. That's not how it works. There's a difference between climate and weather, and there are fluctuations, and we see the trend, and we know that our climate is changing. But it does not imply that from now on, the next day will be always hotter as the day before. That's not how it works.
Exactly. And for all its faults, that's actually a thing I liked that this movie at least brought up. That things are not... I mean, of course, the sequence of events, it was overwhelming to say the least, but I like that they tried to show that... I'm struggling with saying trying to show, because it really wasn't a movie designed to educate you on something. But
I have something for that once you finished.
Okay, but that they made the effort to try and show how complex these systems work.
Yeah, exactly, and that is the next point I want to make, because there's one thing I also researched, I have found, and this was a survey study, which was done 4 weeks or 3 to 4 weeks after the movie was released. So keep in mind, it was very close when the movie was released, and I don't think it would have had an impact over a long period of time, but anyway. And they asked people, first of all, if they watched the movie or not, and then they asked some questions about our climate. And there was this question where they asked, like, there were representative images of how our climate system works. And these are the exact images that we've seen in our classes. Like, you have a ball in a half circle, and like a half pipe, demonstrating a stable system, because if you would dip the half circle and then put it back to where it was, the ball would, be at some point pushed back into the center. You know what I mean?
Yeah, it's basically a kind of equilibrium.
Exactly, an equilibrium. And then there was an image like with a hill and the ball was in the hill, and if there would be a slight dip, then the ball would just fall off the hill. There's no equilibrium. There's it is an equilibrium, but a small change could, destroy it.
Yeah.
And then there was
it doesn't just roll up one end, then the other, and lose energy into a stable state. It's not. It's basically not pendulum-like.
Yeah. And then there was just a line with a ball on the line, like demonstrating a random and unpredictable state where nobody knows what will happen next. And then there was a metastable picture, like a ball in a small depression. So it was stable in its position, but the edges were not that high, which means that a small change and the ball would be still in equilibrium at some point, but if the change be too large, the ball will flip off. And then they asked people that what of these pictures would represent your opinion on how the climate works.
Mm-hmm.
And for all non-watchers, they thought that the completely random and unpredictable is the most likely. But for the watchers, they all said that the metastable phase where small things and small changes and it will return to equilibrium, but larger changes would abrupt and end at catastrophe. Or not catastrophe, but would, abrupt just the equilibrium. Watchers thought that would be the most likely. So they actually realized that climate is more complex as just being random or we have no influence on it.
Mm.
And I thought that was extremely interesting. That people actually took that home from that movie.
Yeah.
And also watchers were more likely to be more careful about climate change now. But also 40% of the watchers were now afraid of a new ice age. So, but again, this was just 3 weeks after the movie.
I always find it interesting because I think at least many people I know are of the opinion that such movies don't really influence things. It's like, people can differentiate fact from fiction. And I don't know, the more often you hear of cases like that, and it's pretty frequent that I myself, I work in the Natural History Museum, and whenever you speak to visitors, it becomes pretty clear that people take a lot from movies. They take a lot from movies which they take as fact. So, especially Jurassic Park dinosaurs.
Yeah.
People do very much take a lot from these movies and take it as kind of fact. Movies have a strong influence on the perception of science, and stuff like this makes this abundantly clear, like this survey.
Yeah.
And in this case, it doesn't even only have negative effects. I mean, you said that there were people among them actually being more concerned about the climate.
Yeah.
So
At least 3 weeks.
yeah, that's the other thing. How long term are these things? But there is a potential for these movies to be a true help. But on the other hand, it's also they are the cause of a lot of misconceptions.
Yeah,
unfortunately.
I think the danger is here when a movie tries to stick to reality, to most or many parts, so that it's more easier to understand or like to find a connection. But then does something that does absolutely not anything have to do with reality, they are more likely to project it on reality. Like if you have a movie, and I don't know, a fantasy movie about dragons, and I don't know, then no one would be afraid of dragons from now on. But if you have like a movie where we have a real life scenario, and then we have, for example, in Jurassic Park, and suddenly, it seems more realistic, and people are more likely to take certain thing as facts or real dangers.
Yeah, absolutely. It's difficult. I mean, maybe we should put dragons in every universe in which any disaster movie is set, just to make it clear that stuff doesn't work that way. But then again, it wouldn't really be a disaster movie.
Yeah,
that's why I kind of like movies such as Deep Impact. I don't know whether you know it.
I know it, but I think I've never watched it now thinking of it.
Guess we've got our next one, because it's basically Armageddon without Bruce Willis and with a bit more. I don't want to say. Honestly, I would also have to rewatch it, but I think that Deep Impact.
I think we have an idea for an episode in the future.
Yeah, but I think it handled it better because it was, as I remember it, it was a rather plausible scenario. I mean, of course, they blow up the asteroid, but one fragment still hits Earth, and it's kind of... I don't know, there's a way... What I want to say is that there's a way to handle these things. There definitely is, and there is a way, I think, where you can try and portray things interestingly, but I think it's difficult with something like climate, because you would have to set this movie in a multi-generational setting, and how do you want to bond to characters if you have a constant replacement of the old ones? And yeah, it's difficult to handle, but
yeah, I also don't mean like don't do these movies. I think the important part here is, or the important point is, how important science communication and education is, and that's like the part that I think things like these show.
Yeah.
It is important to watch these movies, but then understand or realize what things are more likely to be real, and what things are more likely to be unrealistic, like just a sense for what is the word for that, and then skeptic sense, like just to understanding what you can take from it and what where you have to be careful.
Maybe there should be a disclaimer at the beginning of each movie explaining that things don't work that way. Honestly, I mean, we laugh about it, and you keep getting these responses with, it's just a movie, don't take it too seriously. But then on the other hand, people seem not always to notice that it's just a movie. And that's why I don't really think that this idea with disclaimers that things don't work that way are misplaced. It seems kind of overdone. It seems maybe to be too nitpicky to some, but especially today, where I don't know, I think that I'm always hesitant to say that times are changing and people don't read up on as much stuff as they used to, because I don't know, is it really like that? It's just that
I know what you were trying to say, but it is just a very difficult topic. Like for me, there's one example which I'm really annoyed by. It doesn't really do any harm, but I'm just annoyed by. And this is like in all the movies, when there's a hole in a spacecraft, everyone is pushed out and like sucked out. Because of course a vacuum sucks, but no, a vacuum does not suck. It's just here on Earth because the atmosphere is pushing on it. And there, for example, there is little holes in the space station which they had to cover up from inside. And I was asked by a person why this could be the case. Wouldn't it be completely destroyed because all the air would be sucked out and the people would like suck to the hole and it would destroy the space station? And it's a very common thing that people think this, but no, a small hole would not change much. There would be a leak and air would escape, but would be not sucked out. It would be escaped gradually, It will be rather pushed out because there's a lot of air within the ISS, So yeah, it's not really, it doesn't do any harm and it's connected to the topic, but just movies can imply these things and they have a larger influence as they would think sometimes.
Absolutely. It's just this very weird relationship we have to movies. On the one hand, we know not to take them for a fact, and on the other hand,
that someone does.
Yeah, there is substantial evidence out there that people do take these movies seriously to a degree, or at least, you were getting at that there is not really a skeptical sense embedded in people many times. And not everybody needs to be a skeptic. Not everybody needs to understand everything that's going on in these movies. But I think that at times it's harmful. And I mean, it's like with things like understanding how a vacuum works. That's, of course, it's completely irrelevant for you as a person. But especially from my perspective, with paleontology, with Jurassic Park, it's also one of those cases, it's, who cares? Honestly, what does average Joe have from knowing what dinosaurs looked like? But what I think is pretty important is that people do have a basic understanding of how the world around us works. Because, I see this messenger function, especially in a way where paleontology tries to create a consciousness that life is connected to one single starting point. To show that we all are not that much different. The more we learn about ourselves, the more we seem to get that, hey, we're not that different from other animals. Paleontology can maybe try and create a consciousness that we're all connected, which could lead to people caring more about other creatures, which could lead to us existing together on this planet. I mean, this is completely exaggerated and idealized, because reality doesn't work that way. But this is what movies can actively work against by, jinking this, by altering this picture people have. And that's why I mean, it's inconsequential. These factoids people might get wrong. It's inconsequential, but it might harm the bigger picture.
Yeah. The point is, these movies should not do any harm. Normally, you should watch these movies, it's a movie and it's done. You can enjoy the movie if you are in like that kind of stuff. Okay, it's done. But the point is that everyone should know and realize that that's just not reality. Like, as you said, nobody has to know exactly how dinosaur, XY looked like. But they should at least understand that it's just a movie and they do not look like as portrayed in the movie, Just a sense and understanding of our reality, as you said, and the understanding of the real life around us.
And I mean, we are all involved because what we decide, who we decide to vote for, is influenced by how we see the world. And
exactly
who we vote for influences how this world is going to change and go. And that's why, movies, it's just a facet of many, many, many things influencing all of us. But it's not negligible.
I mean, sorry, yeah.
No, just go on. It's okay. I was pretty much done.
I wanted just to come back to the movie partly and say, like, for example, climate change, we have to do something. Yeah. But when people start believing that climate change isn't real, they of course are voting for people that also say we don't have to do something against climate change, which would result in stronger climate change, just because some people don't want to accept it, that there is something in their life that maybe they don't understand, or maybe they don't want to understand, don't want to happen. And so these maybe, I don't know, wrong kind of understanding of our real world, of our universe, can lead to decision making that can be really bad in the end.
Yeah. I mean, really, movies are just such a small facet of all this, but
yeah,
misunderstanding and not being informed. I mean, who of us is informed on everything, really? We all make mistakes every day or get things wrong every day. That's normal, but movies are just such a tricky topic. And once again, it might sound ridiculous, but I think there should be some kind of disclaimer that this wouldn't happen like that.
I'm actually with there 100%. Like, it sounds stupid, but yeah, just at the start of the movie be like, this movie maybe is based on realistic circumstances, but the rest of the movie is completely...
This movie is inspired by hypothetical things that could happen in reality and is not based on real life events.
And is highly exaggerated.
Yeah. I don't know, it's... Yeah, but I mean, we went on a tangent here, but I think this is a topic that needs to be discussed. And you hear this being discussed in the scientific community all the time, that movies are a tricky topic, and all the time when a movie about one specific field of research comes out, you hear scientists scoffing because what are they gonna butcher this time? And the thing is, sometimes reality actually is fascinating enough and you don't need to alter it all that much. The time frame is often the problem.
Yeah, exactly.
Yeah.
So again, we're not saying that these movies shouldn't be made, but there should be just in general a more better sense for the real world in humanity in general, so that we can all enjoy these movies on the same level.
The problem is just you could fill hours with this conversation.
Yeah.
I think what it boils down to for me is that it's a tricky topic, of course, but yeah, we keep saying that movies aren't really... We tend to say don't take it too seriously, but people do take it seriously in a way. And that's the same with this movie. I gotta say I liked it more than, or at least I can forgive a lot of its faults now that we've discussed it. I still would say it's one of the more confusing movies out there.
Yeah.
Just because...
And just after the science part, the writing was horrible. I'm sorry.
Yeah. It was just pretty much a turn your brain off movie.
Anyway, I think we're talking now for quite some time if I'm looking at my timer.
Indeed.
So I guess we should wrap up now.
Yeah, I think so too.
But I really liked our discussion in the end. I hope you learned something, maybe. Something you haven't known. Maybe.
Oh yeah, I did definitely.
Yeah, I mean, I learned a lot after researching stuff. Like seeing large hailcorns and asking the question, wait, how large can hailcorns actually be? And then I searched for the influence of climate change on hail cores.
Yeah. The thing is, like, you keep being the scientist, and what I'm thinking right now is maybe that next time we could review something more paleontology centered. I actually, I mean, Jurassic Park, it's been done to death. Maybe we could grab out some of these older documentaries.
Yeah, that would be nice.
I'm specifically thinking of Planet Dinosaur right now.
Wait, Planet Dinosaur war die letzten Jahre der Dinosaurier?
Yeah, indeed. And translation, the last years of the dinosaurs.
Yeah.
The one which doesn't take place during the last days of the dinosaurs. At least mostly, I think. Maybe we could do that.
Yeah, or Prehistoric Park or something like that in the future.
Yeah. I don't know.
Yeah.
But that would be my idea right now.
That's a very good idea.
Because then you can be the narrator and I will do more research.
All right. Okay. So with that, thank you for watching. And we will see or hear each other. You will hear me or us the next time.
All right. Now my voice gave in at the last moment.
A very chaotic ending.
Yeah. Bye, guys.
Bye.
Thanks for listening to the RockyTerrain podcast. If you enjoyed listening to us, please consider subscribing on your favorite podcast platform. Everything addressed in this podcast reflects our own opinion. You can contact us at 4.5GAinthemaking@gmail.com. That is 4.5GAinthemaking@gmail.com. All music used is from Kevin MacLeod and was downloaded from filmmusic.io under the Creative Commons license. That is Heavy Interlude for intro and outro, and Home Bass Groove for intermission.
Okay.
The day after tomorrow is gonna be Sunday. Sunday used to be fun. Sunday used to be the day on which I don't work.
I never liked Sundays. As a child, I hated them.
I hate sand. I don't like sand. That's what he says.
Yeah.
Let's just keep talking about Anakin. It's fascinating character. Great dialogues.